In this video, I'm going to solve this question. Before I start solving this question, make sure that you have a basic understanding of the concept of p-value. If you need some help with the concept of p-value, then you can have a look at our course on hypothesis testing, in which we have covered all the concepts in a detailed manner. You may check the description of this video to get the access link to the course. All that said, let's get started with this question. A random sample of soil specimens was obtained and the amount of organic matter in the soil was determined for each specimen, resulting in the accompanying data. So this is the sample data that we are given. The values of the sample mean, sample standard deviation and standard error of the mean are these. Does this data suggest that the true average percentage of organic matter in such soil is something other than 3%? Carry out a test of the appropriate hypothesis at significance level 10% by first determining the p-value. Would your conclusion be different if alpha equal to 5% had been used? So first of all, let's say that mu is the true average percentage of organic matter in soil. So mu is true average percentage of organic matter in soil. Now our first step is to write the null and the alternate hypothesis. And to do that, let's have a look at the claim that is made in the question. So it says that the true average percentage of organic matter in such soil is something other than 3%. So that means the claim is mu is not equal to 3. So the counterclaim of this claim would be mu equal to 3. And because this claim has an equal to sign, so this claim is our null hypothesis, and consequently this claim is our alternate hypothesis. Now because the alternate hypothesis has a not equal to sign, so this means that this is a case of two-tailed test. So this is a case of two-tailed test. Now after stating the null and the alternate hypothesis, let us write all the information that is given in the question. So we are given that the sample mean is 2.481. So x bar is 2.481. You can also call it x bar calculated. The sample standard deviation is 1.616 and the standard error is equal to 0.295. And we are given that the significance level is 0.10. So alpha is equal to 0.10. And from here we can see that we have 30 observations in the data. So that means our n is equal to 30. So n is equal to 30. So this is the information that is given to us. Now with all this information, let's talk about the distribution of the sample mean and the rejection region. Note that we are not given any information about the distribution of the population in the question, but we know that our sample size is large enough to use central limit theorem. And using central limit theorem, we can say that the distribution of sample mean will be approximately normal in this case. So the sample mean will be approximately normally distributed. So that means this is how the distribution of the sample mean may look like. Recall that we are given that the hypothesized population mean is equal to 3. So that means we can write 3 here. And the observed sample statistic, that is your x bar, is equal to 2.481. So it may be somewhere here to the left of 3. Let's say 2.481 is here. And we are also given that the value of alpha is 0.10. And this is the case of two-tailed test. So that means we will have a rejection region on the left-hand side and we will have a rejection region on the right-hand side. So we will have one rejection region here and we can just divide the value of alpha into two parts. So this will be 0.05 and one rejection region here and this will be 0.05. Now given all this information and the setup, let us see how to calculate the p-value. Well, the rule is in case of a two-tailed test, the p-value area is the area towards the tail that is closest to the observed sample statistic. In this case, our observed sample statistic, that is the observed sample mean, is 2.481, and this is closest to the left tail. So this implies that to find the p-value, we have to calculate the probability of this shaded region. And note that once we calculate this probability value will not be our p-value. To find the p-value, we will have to multiply this probability by 2. So this is how it works in two-tailed test. Now let's take it step by step. So we have to find the probability of this shaded region. Now the question is that how do we find the probability of this shaded region, whether we use the Z distribution or the T distribution. Note that we are not given any information about sigma, that is the population standard deviation. So we don't know the value of sigma. But our sample size is equal to 30, which is actually considered a large enough sample size. And the rule is that even if the population standard deviation is not given, when we are dealing with a large sample size, we can safely use Z test. And the Z formula in this case is equal to x bar minus mu divided by S divided by under root of n. So we have just replaced sigma by S in the Z formula, and we can do this because we are dealing with a large sample size. And by large sample size, we mean that the sample size should be at least 30, which is the case here. Note that the mu here in this formula is equal to the value of mu under the null hypothesis. And under the null hypothesis, the value of mu is equal to 3. So this is equal to 3. So the Z value corresponding to x bar equal to 3 will be equal to 0 because the numerator will become 0. Now let's find the Z value corresponding to x bar equal to 2.481. So the Z value is equal to 2.481 minus 3. We are given that the sample standard deviation is 1.616 and the sample size is 30. Solving this, we get that Z is equal to minus 1.759. So the Z value corresponding to this value of x bar is minus 1.759. So this means our problem boils down to something like this. So let's say this is the standard normal distribution. And here we have 0. And here we have Z equal to minus 1.759. And all we have to do now is we have to find the probability of this shaded region. Finding this probability should not be a difficult task. There are a couple of methods that you can use to find this probability. Because the Z value that you are given here is negative, so either we can use the negative cumulative probability table or we can invoke the symmetry rule to find this probability. For this example, I'm going to use the negative cumulative probability table. So let's have a look at the table now. So this is the negative cumulative probability table, and from this table we have to find the probability corresponding to a Z value of minus 1.759. Well, we can round it off and we can say that we have to find the probability corresponding to the Z value of minus 1.76, and that probability is this 0.0392. So the probability corresponding to Z equal to minus 1.76 is 0.0392. So we can write that this is 0.0392. Note that this probability value is not your p-value. To find the correct p-value, you have to multiply this probability by 2. So p-value is equal to 0.0392 multiplied by 2, and this is equal to 0.0784. So this is your p-value. Now let's see whether we should reject the null hypothesis or not reject the null hypothesis. Note that we are given in the question that the value of alpha is equal to 0.10. So this is the level of significance. And as you can see in this case, the p-value is less than alpha. So the p-value is less than alpha. And when this is the case, we reject the null hypothesis. So this implies that we are going to reject the null hypothesis. Just to make you recall, our null hypothesis was that mu is equal to 3. And in this case, we are rejecting the null hypothesis. So we can say that there is not sufficient evidence that the true average percentage of organic matter in soil is 3%. So this is all about the part A of this question. We also have a part B in this question, and the part B is that would your conclusion be different if alpha equal to 0.05 had been used? So now the value of alpha that we have to use is 0.05. Now because the alpha is 0.05, our p-value is greater than alpha. And when this is the case, we do not reject the null hypothesis. So if alpha equal to 0.05, we will not reject the null hypothesis. And this is all for this question.